our union, infinite, n equal 1, 5 plus 1 over n squared to infinity is equal to 5 to infinity. This side we let you see. So now we're gonna do it that direction. So we'll be starting on that side. And we want to get to this side. So we will start by doing the opposite. Let x exist in the interval 5 to 8. And similarly, I would like to write a goal. Our goal is to show that x exists in the union n equals 1 for this interval, and that is equivalent to there existing an n in naturals such that x is in one of these intervals. So x is in 5 plus 1 over n squared to infinity. And to write that as a comparison with less than or equal signs, it would look like this. So again, x will be between these values. And an important step that we must take is the Archimedean principle, actually. Can there be an n in naturals such that x is greater than or equal to 5 plus 1 over n squared? If we solve for n, we'll see if there is or not. So subtract 5 on both sides, and then multiply by n squared. So we'll have 1 less than or equal to x minus 5 times n squared, and then divide by x minus 5 on both sides. Now, and take the square root, and we get that n will be greater than or equal to the square root of 1 over x minus 5. And since this value right here exists in real numbers, because we said x will be from 5 to infinity, not including 5, so we can't get 0 in the denominator there. It's going to exist in real numbers. So we let this be true. So now we, again, won't get a 0 in the denominator here. So this value can exist in real numbers. So by the Archimedean principle, I'll write that down over here. 1 over x minus 5 exists in real numbers by Archimedean principle. There will exist an n in naturals such that this value can be true. And now that we know that, we will work with it to kind of like solve for x. So we'll be working our way back, square both sides. Multiply by x minus 5. And then divide by n squared. 1 over n squared will be less than or equal to x minus 5. And add 5 to both sides. So now we have x is greater than or equal to 5 plus 1 over n squared. But x is also less than infinity, as it's not included within the range. So we write that there. So as we can see, we have reached similar intervals that we want to have written. So now we write the extra piece needed here. So there does exist an n in naturals such that this is true, such that I want to write the one above it, such that, sorry, I hardly have any space now, x exists in this interval n squared to infinity. And I'll just write up here therefore x exists in the union from this interval and since we proved both ways of the subset, that means henceforth the union of b to the n is equal to the interval from 5 to infinity.